Hey Matthews, we're back with some more statistics. We're looking at the second part, which is measures of center, so mean, median, and mode. I know you've seen mean, median, and mode ad nauseum, and that's why I don't want to go way in depth with it, but the mode is what occurs most, and we call it bimodal if it has two modes. Like, for instance, this data set is, I don't know, the IB scores or something like that. This has a mode of 3, but wait, there's also two sevens, so bimodal. This is pi as a mode because pi shows up more times, and so like instead of pi a la mode. Anyway, if you find that a data set is multimodal, like there's two 8s, then you stop talking about mode as a measure of the center. Measure of the center is like, here's all my data. Where's the middle? Like, give me a, like, you know, what, looking at everybody's ages in the room. It's just me right now, but looking at everybody's ages in the room, kind of on average, what is the, you know, what's everybody's age? Well, you could use mode or median or mean. Median is just the middle number if you add them all up. So if you look through them, so one way to do that is slash one off of each side until you get to the middle. Oh, the middle, there's two numbers, so take the mean now. So 3.5 would be the median. Or one way to do that, another way to do that that's more algebraic is look at how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8. That's this 8. You add 1 to it to find the middle if there's an even number of integers. And then divide by 2. So this gives you 9 over 2, gives you 4.5. That means the 4.5th term thing you see is the mean. So that's the first term, not that one. Second, third, fourth. It's not a term, it's an entry. So between the fourth and the fifth, and then you take the average. This is helpful when you have a really long set. You're familiar with the mean. It's just the sum of all the datas over the number of numbers. But it becomes a little more tricky when you have a frequency table. Here's an example that might clarify that. If you just polled a whole bunch of people to see how many countries they visited over break, and one person said 3 countries were visited, another person visited 4, 3 people visited 5, etc., etc. That's how you would read this. But if you're trying to find the mean of how, on average, how many countries were visited, you'd have to look at how many countries total were visited, how many country visits. So one person visited 3, that's 3 country visits. 4 country visits. This should be 15 country visits because 3 people visited 5 countries, so there's 15 countries visited, etc., etc., etc. And then you can add those up together. All right, so 278 country visits have occurred over summer, and 40 students have weighed in on that. Right, this is 40 students if you add them up. So to find the mean, you'd say that this is 278 and this is the 40, and your average is around 7, which looks to be the case because this was the mode, and so it's also the mode and the mean are in a similar spot. You might call these the data value, the frequency, and the product of the two. So you can try the same thing here. We're talking about aces served by a tennis player, and aces when you serve the ball and the opponent can't return it to you. So 4 people served 1 ace, 11 people had 2 aces, etc., etc. What I'd like you to try to find is the mean, median, and mode for the data, meaning what's the average, the mean for how many aces served, what's the median, what's the mode. Here's the frequency table start. Maybe you want to continue with a product table and a cumulative frequency table, and that'll help you see what's going on there. Try that. Overall, I know that we're talking about, if you add all these up, I know we're talking about 55 tennis players. 4 people served 1 ace, so that's 4 aces accounted for. 11 people served 2 aces, so there's 22 aces counted up, etc., etc. And if you add those all up, you end up at 179 aces served. So if we divide those two, if we say 179 aces occurred over 55 people, you end up with 3.2 aces each, which seems like it'd be right. Like, you can see that they're kind of clustered in here. because these are the mode is 3. Oh, I gave it away. C. The mode is 3. It happens the most frequently. The median is not 3.5. It's not that we scratch this and this and this and this and then average these two. We're talking about the number of aces. So what you'd have, one way to do this is write out all of the data set. And here's the data set. This is 1 happens 4 times. 2 happens 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 happens 18 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 18, right? And so you can see this happening there. And one way to do this is to walk through and go scratch 1 from that side, scratch 1 from that side, boom, boom, until you get someplace into the middle, right? You find the middle that way. A smoother way to do that is to look at how many entries there are overall. Add them up. We've already done that though. There's 55. Then you can say what we did before. You say the 55 plus 1. So to find the middle, you can say n plus 1 over 2 gives you the sort of the term number, the entry number. And so that's going to be, so 28. The 28th entry in. So then you could count 1, 2, 3, 4, get to 28. Or you can start at the bottom and count and say, okay, 4, here's 4 been counted. Now here's 11, so now we're talking about 15. And 18 more, we are not to 28 yet, so it must be into 4. You see that happening? Otherwise, you could use a cumulative frequency table and say 4 have been counted. 11 more have been, 18 more have been counted. 33. Oh, so there we go. We're at 33, we're looking for 28, so it is in 3. So the median is 3. Alternately, you can do this on your calculator. Here's steps to do that on your calculator. I'm going to use that same data we've been looking at with the tennis serves. Here's my fancy calculator, and here's the run through on how to work with it. That's what these pictures behind look like. But hit stats and hit edit. And then the slow way, I'll show you the fast way in a second, is to put all of this data in list 1. And so you say, oh, where'd you go? You'd say stats, edit, and in list 1 you'd say I have 4 1s and 11 2s. And so I put all of that data in. Boring. But then you go back to stats, you say calc, 1 variable statistics. Oh, pay no attention to that. Usually you'll see this, just list 1, go down to calculate, boom, boom, and it says 3.2, as this is the X with a hat is a mean. N is the number of numbers that you see, so 57. What else do you see in there? The median is 3. And did they give us the mode? I don't think they give us the mode. Okay, so that's one way to do it. A smoother way to do it is take that same data and actually I want this piece. There it is. And I want to be able to use a frequency table with my calculator. So we're going to do the same thing. Go into stat, go into edit. I'm going to clear out this. You go up into L1, you hit clear, you go down, and it'll clear it for you. And this is the way to enter a frequency table. I know I get 1 aces, 2 aces, 3, 4, 5, or 6. And then in L2, then you put in the number of those occurring. So 4, 11, 18, 18, 13, 7, 2. Now the tricky bit is when you go back into stats and you say calculate and 1 variable statistics, it says where's my numbers? Oh, they're in list 1. But treat list 2 as the frequency of those said numbers, the corresponding numbers. So then you have to say second L2, which is over the 2, and then say calculate, and it should give you the exact same thing. The only thing is why this is better is that you don't have to put in all of these numbers by hand, because that's tedious and awful, and you have better things to do like play Candy Crush. So that's how you get list 2 in there. You can see how these measures of center changed the shape, or how the shape changes based on those measures of center. Usually the mean, median, and mode are all in the center if you have an even distribution, like ages in the classroom. Nobody's in the classroom right now, but most of you would be about, I don't know, what, 17, something like that. And there would be some that are a little younger and some that are a little older before I walk in. Once I walk in, then I'm 90, and the mode would still probably be like 17, and Mr. G is 90, right? So it pulls everything up, and we say that it's skewed in the positive direction. It means the tail is pulled positively. I guess it's this way for you, pulled positively. So this is positive skew. If Leonie, my daughter, walks in, she's 3, and I'm not there, I leave the room, I'm like, she's smarter than me anyway, go in there. She skews the ages to the negative direction, right? The bulk of it, the middle of it, is still around 17. But it moves the median a little bit, and it moves the mean even more. I know that we always feel like the mean should be the middle, but it feels the most skew based on these outlying data. Maybe they're not outliers, but the mean moves the most, and the median really doesn't move as much. We call it resistant, and often like the median gets overlooked as the best measure of center. Let me give you a idea of how to see that. Yeah. There we go. So let's call these ages in a, I don't know, judo class, and there's one 8-year-old, and here's a 9-year-old, and here's another 9-year-old. This is the mean, the median, and mode. And so I'm going to set up a little bulk here. Most of the kids are 7 and 8 in a group. I don't know. So let's bulk this out a little bit. It doesn't have to be symmetrical, but there. Mean, median, and mode are all pretty similar, and this curve, this frequency curve, looks like a nice bell curve. If you add an older kid in, you saw the mean move, but the median and the mode didn't move at all. And as you add more 15-year-olds, really like the mean moves a lot, and the median doesn't move a whole lot, right? And you can put a lot of 15-year-olds in, and you can see that now I have 2 modes. This is bimodal now. So I probably wouldn't use mode as the measure of center. You're like, hey, if you ask how old most of the kids are, like on average, like what most of the kids' ages in this group? Probably I'd still say they're around 7 and 8, but I have like these group of 15-year-olds. Maybe they're the instructors or something like that, or the helpers. And they drastically move the mean up, although the median is still what we'd expect, 7 or 8, right? You'd say that mostly this group is made up out of 7 and 8-year-olds. Yes, there's a 4-year-old, and yes, there's an 11-year-old, but most of them are best represented by the mean and no longer the median. Really, most of these kids aren't 9 years old. We'd say the mean says 9 years old because they're this group of 15-year-olds that's dragging everything that way. Interesting. So that's a nice site for playing with this and seeing the distribution. I can put it up on Schoology. Cool. There's some problems to work out, and I'll see you later. Bye.